here's the equation we're getting set up with. Okay, now here's the thing, right? You know how we did talk before about one-step and two-step equations, okay? Here's the thing. Addition, subtraction, multiplication, division. That's basically all the tools they're using to make these equations, okay? But there are so many combinations of ways to put these together, right? That thinking about these categories stops being useful. You look at this and you're like, what are exactly the one step or two steps that you do? So what I'm going to do, instead of saying, look, here's the same thing you do over and over again, I'm going to try and give you a general set of strategies that will always be useful no matter what you've got for these kinds of equations. And it might be 3 or 4 or more steps, but it doesn't matter how many steps, the strategies will still apply, okay? So, we are trying to solve this thing, right? That's the question. Solve this. In other words, we want to find a value of x that'll work. We want the key that'll unlock the equation and make it actually correct, okay? So, how am I going to do this? Here's my general strategy number 1. Okay, so maybe you want to write this off on the side, and then we're going to do it here. Okay, the first strategy is collect like terms. Okay, now we looked at collecting like terms before in algebra without equations in the picture. Okay, so for instance, let me just give you an example off on the side. You don't have to write it down, but look up at it so you can follow it with me. You might have gotten something like this. Okay, there you go. This is not an equation. It's not an equation. Why not?
It doesn't have equal sign.
No equal sign. So it's just an expression, right? But I can still simplify it. Okay? The way that I would do it, and we've seen this before, is you would collect like terms. You're looking for these things that are kind of similar to each other, right? Now I can see a couple of pairs of different things that I can combine together. For instance, any takers? First thing, yeah. The M's, good. I've got 6 M's here, right? And if you have another color, that'll help you as you go through this, right? I've got 6 of them here, and I've got 3 here, right? So I'm going to have 9. So I'm going to write that as 9M. I've collected those terms. Cool. Then I've got the other terms. They don't have any letters on them. So what we call them is, these are just the constants, okay? These numbers. So there's -7 and +2. And you got to watch out for the sign. It's a bit sneaky, right? -7 plus 2. If I write them off on the side, -7 plus 2. What's that equal to? It's going to be, if I have, there's the number line here, right? There's 0, and there'd be -1, 2, 3, 4, 5, 6, 7, because negatives this way, okay? Plus 2 means go 2 over, and that's why, as you said, -5. So I'm going to take these two terms and I collect them, and that's what I've got. Yep. Ah, right. Okay. So the question about what makes a like term, what makes like terms alike, right, is more about these things here, what's attached to the number, less than whether it's positive or negative. Okay. We can mix together positive and negative numbers, and they're okay, right? But you can't mix together M's and 2's. Right? They don't gel together. 3M plus 2, there's no way you can simplify it. It's just 3M plus 2. Okay. So that's why you've got these two, they're like terms, right? And then you've got these two, they're like terms. Okay, good. Now we're going to do a very similar thing over here. The last question I got on this was, how do I know whether this is +9 or -9?
It doesn't have positive or negative.
It's positive.
It's positive. The reason why is because up here, right, you look at the signs of your original numbers. Now, I know there's no sign on this one, but it's because hiding, right? If I said, I've got 5 shirts, right? You don't think, oh, is it positive or negative? If you just see a number, you assume it's positive, right? So I've got +6, +3. That's why it's +9. There are no negatives at all that come into play there. Okay? When there are, then we can account for it. And that's why it's a -5, -5. All right, good. Good question. Does anyone have any other questions on that? Does it make sense? Okay. We're going to do much the same kind of thing here. But the equal sign changes things very, very slightly. Okay? What are we working toward? What's your final line? What's it going to look like? It's going to have x equals and then a number, right? I suppose you could say some number equals x, but that's a bit of an awkward way to write it, okay? So when you have a look here, right, I'm not just going to collect my terms wherever I like. I want the x's to be on the left-hand side, okay? So watch. Where's my, here it is. Where are the x terms? There's a pair of them, right? There's a 6x and a 5x. I'm going to circle them, and I encourage you to do the same, okay? At the moment, there are just two, okay? And so they're not that hard to spot, but sometimes there will be more than two. There are 3 or 4 or 5, and you have to make sure you don't miss any of them. That's the point of collecting them, right? Okay, now, I want them to be on this side and not this side, right? So another way of saying that is I want to get rid of all of the x's on this side and push them over to this side. So what should I do to both sides of the equation to get rid of all of the x's on this side? Okay, all right. You're getting after something important here, okay? It is weird having something over here and something over here interacting with each other. I'm going to show you how they will, okay? At the moment, here's my goal, and I'll show you how it'll work.
Wouldn't that be like...
I want to get rid of all the x's over here. No, same question, okay? Here's my goal. I want to collect like terms. I want all of the x's not to be spread out across both sides. I want them all on this side, not on this side. So here's what I'll do. Remember, when it's an equation, right? You've got to do the same thing to both sides all the time so it stays equal, right? If you had 2x equals 10, what would you do both sides? You would divide by 2, wouldn't you? And that would give you this. It's still working, yeah, that's right. Okay. If I had this, okay, what would I do to both sides? I would take away 1. That would give me x and 9. So these are okay, and these are okay. Now what I want to do here is I want to get rid of all these x's over here. There's 5 of them, right? So what I'm going to do is I'll take away 5x. Can you see? That's going to get rid of all of these x's on this side. But of course, as we've just demonstrated, you can't just take something away from one side and not the other. So I have to take 5x away from this side also. Okay, can you see what I've done? Is that alright? This second line, all it is this part I got from the first line, and then I subtracted 5x from the left and the right. It's still balanced out, right? Still balanced, still balanced, still balanced. Okay? Alright, now, why did I choose to subtract 5x? It was because I would get rid of all the x's on this side. What's going to happen to the right hand side? 5x cancels with this, so you just end up with 7. Okay? Now what's going to happen on the left hand side? Well, the x's aren't going to cancel because it's not the same number. I'm going to collect like terms over here. I've got 6x minus 5x. You see that? So how many x's will I have left? Just the 1.
Oh, 1, sorry.
6 minus 5?
50.
Now,
50.
I collected the x's over there, but there's still that 5 there. He's hanging around. So there you go. X plus 5. You see what I did? So again, let me try and highlight for you. This 6x and this minus 5x, they came together. I collected them and they just became 1x there. That plus 5 from here just sort of hangs on.
Huh? Oh.
Anyway. Alright. Now, I'm almost done, right? This is the kind of equation which we saw like early in the exercise. I suppose you would call this a one-step equation, wouldn't you? What do I do? What do I do to both sides to get x by itself?
Minus 5.
I take away 5.
X equals 2.
Ta-da. Done. Okay. Now, the great thing about this, remember, I keep saying, the great thing about equations is that if you get an answer at the end, there's never any doubt as to whether you got it right. I should be able to chuck it up here and see what happens, and it should work, right? You don't have to do this, but just for the sake of it, let's just make sure that we got it right. What's the left-hand side going to be equal to? It's going to be 6 times x, which is 2, plus 5. What's 6 times 2? 12 plus 5 is 17. Okay, what do I get on the right-hand side? I get, well, let's just make sure. I got 5 times x, which is 2, plus 7, which is 10 plus 7, which is 17. It works. And so that's how you can know x equals 2 is correct. Okay. So, I didn't write it down. First, we collected like terms, okay? And then what we did was we simplified. When you simplify after that, what you'll get down to is something which you're very familiar with. You know how to solve these, okay? So it's taking a problem which is more complicated and sort of working at it and chipping away until it's something that you do know how to do with, okay? Collecting like terms and simplifying, no matter how many steps your equation will be, is always going to be a helpful pair of strategies that you can use to get to your answer, okay?